We're going to introduce angles today, and in this lesson, one of the things we need to be able to do is name an angle in multiple ways. So you can see we have an angle here. It's got a point X, a point Y, and a point Z. This point right here is called the vertex. That is the bend in the angle. It's the middle of the angle. This angle starts at X, goes to Y, and then Z. And if you follow it with your pencil, we could call this angle X, Y, Z. Because I start at X, I go to Y, and I go to Z. And the vertex will always be the middle letter. You could also name this a different way. We could start up here, an angle, we could start up there at point Z, and we could call it angle ZYX. But the order is important. These are two ways to name it. Now, because there's no other angles on this picture, it's just this one angle, we could get away with simply calling it angle Y, because there's only one angle here, and Y is the vertex. We could not call it angle X. There's no angle here. The angle starts here. And sometimes you'll see a number, like this might have a 1 in here. And then we could also call it angle 1. So there's 4 ways to name that angle. Let's take a look at another angle. This one's got a unique symbol here. It's got this guy, and that stands for the fact that this is a right angle. And so the measure of this angle is 90 degrees. That's a right angle, and that's what that symbol means. It's got K at the vertex, and it's got 2 sides. You know, we didn't name the sides before, but let's go ahead and name them now. This has 2 sides, and one side would be called KJ, and that's a ray. It starts at K and it goes up through J, and then it's got a ray KL, and we call those rays because they have end point at K, and one goes through J and one goes through L. We can call this angle, right now I can call it 3 different things. I could just call it angle K. Sorry, my pen took a hiccup there. I could call it angle K because K is at the vertex. And if I want to call it using 3 letters, I could start up here and go LKJ. So LKJ, and this right here is the angle symbol. And that's the angle symbol. I could call it angle, and I could start up here, JKL. So there's 3 separate ways to name that angle. If there was a number here, like say a 4, then I could call it angle 4, because if I say angle 4, we all would know what I was talking about was this number of degrees right here. The next thing we need to know about are angle relationships, and we're going to look first at a relationship called complementary angles. And complementary angles are angles that add up to 90 degrees. And so sometimes you'll see something that looks like this, a right angle symbol. It'll tell you this whole thing is 90 degrees. And we have one angle here that's 73 degrees, and we want to know what its complement is. This is called the complement because it would add up with 73 to make 90 degrees. And we can write a little equation that says x plus 73 equals 90. Now, if I want to solve for x and find out how many degrees that little angle is, I'm going to solve this equation. We'll take away 73 on both sides, and we get 17. So if this is 73 degrees, this angle has to be 17 degrees because it's complementary. So x equals 17 degrees. Now, the other relationship that we will be looking at are supplementary angles. Now, supplementary angles add up to 180 degrees because they make a straight line, and a straight line, if you take a look at this whole thing, is half a circle, and that'll be 180 degrees. There's 360 degrees in a whole circle. And these 2 angles are supplements of each other, and therefore, if I say x plus 130, if I add those 2 up, it should add up to 180 degrees, which is what's a straight line. We'll take away 130 on both sides, and that's our only step necessary, and x equals 50 degrees. So in this example, x is 50 degrees, and 50 degrees and 130 degrees are called supplements. Now let's come down here to an algebra problem, and you can see that we have three angles here, and I don't even know any of their degrees, but I have expressions. One of them is 5x plus 4. One of them is x minus 2. And the other one is 3x plus 7. Now together, all three of those angles make a straight line, and that straight line is 180 degrees. So our next step in solving this equation is to combine our like terms. So I have 5x and an x, that's 6x plus 3 more is 9x, and then I have 4 plus 4, take away 2 is 2, plus 7 is 9, so I've got plus 9 equals 180 degrees. And all we got to do now is solve it for x. Now that won't tell us any of the measures of any of these angles. 9x equals, that's 171. And when I divide by 9, 9 goes into 171. It looks like it's going to be 19 times. So x is 19. I need to go figure out all these different angles. So if x is 19, this first one will be pretty simple. This right here just says x take away 2. So 19 take away 2. That little one is 17 degrees. That would be angle SOR. So the measure of angle SOR is 17 degrees if you follow the letters SOR. Let's go find this one. X again is 19. That's 3 times 19 plus 7. And 3 times 19 is 57. And 57 plus 7 is 64 degrees. So that is ROQ. So the measure of angle ROQ is 64 degrees. Now I could do this a couple of different ways. I can plug 19 in. I can get 5 times 19 plus 4, that is 95, plus 4 is 99 degrees. And so I know this last one is 99 degrees. And that would be the angle POS or SOP. We'll call it measure of angle SOP. The other way I could have done it was to add these two up and then subtract that from 180. And I would also get 99. And if you take a look in your calculator, 99 plus 64 plus 17 should add up to 180 degrees. The last topic for the day is vertical angles. Vertical angles are directly across from each other, and they share a common vertex. So you can see that angle A and B are directly across from each other. They're formed by these two intersecting lines. This angle is congruent to this angle. So however many degrees angle A is, it's going to be equal to angle B. And you can see two other vertical angles here, and they're also directly across from each other. This angle on the top would be congruent to this angle on the bottom. So let's take a look at this example here. If we're being asked what's the measure of angle X, well, X is directly across from 133 degrees. So that means that X must equal also 133 degrees. Now if I wanted to find out this angle here or this angle here, I don't need to do anything else except subtract 133 from 180, because this is a complete straight line, which is a straight angle. And if you take 180 minus 133, you're going to get 47 degrees. And so this angle is 47 degrees, and since this is vertical, this one is also 47 degrees. So here we have down here this last example. This one here is 76. Well, right away I know that Y equals 76 degrees. Now if I want to find X and Z, they're both the same because they're vertical. They're directly across. All I have to do is subtract 180, take away 76. And I'm going to get 104 degrees. So this angle up here is 104 degrees, and this angle up here, down here, I'm sorry, is 104 degrees. Let's take a look at one last example. Here we don't even have an angle. I just have two algebraic expressions. This side is x plus 16, and this side over here is 4x minus 5, but I know that these are vertical to each other, so they must be equal. And that means that x plus 16 has to equal 4x minus 5, and then we're just going to employ some equation solving. I'm going to move the smaller x first, even though it's going to the right side. I don't really care too much. That 16 is all that's left, and 4x take away x is 3x minus 5. We're going to go ahead and add 5 to both sides and solve this equation. We get 3x equals 21, and when I divide by 3, I get x equals 7. I'm going to turn it around. X is 7. Now, if all I was trying to do was find x, that's the value of x that makes this true. If I want to find out how many degrees this is, well, I got to substitute it back in. 7 plus 16. This side is 23 degrees. So if I did my math right, the other side should also be 23 degrees. That's 4 times x, which is 4 times 7, minus 5. That's 28 minus 5, and that's 23 degrees. So we did that part correctly. If I was trying to find this up here, this whole thing makes a straight line. All I got to do is take 180 and subtract 23, and I would get 157 degrees. So this piece up here is 157 degrees, and this piece down here is also vertical, 157 degrees. That's it.